All right, because this is a review of some skills that we've done in Algebra 1, our lesson is going to be pretty quick today. However, I do want to remind you of a few things before we dive into the actual lesson. So today's lesson is going to be talking about equations of parallel and perpendicular lines. We know parallel are two lines in the same plane that never intersect, and perpendicular are two lines in the same plane that intersect at a 90-degree angle. So since we're talking about lines, let's just do a brief review from Algebra 1. So the first thing I want to talk about is just how to graph lines. Remember, our basic equation is y equals mx plus b, where we start with the b or the y-intercept. So that means I'm going to start at positive 1. And then m is our slope, which we count as rise over run. So a slope of negative 2 over 5 would mean to go down 2 and to the right 5. We can also count that slope backwards to get points on the left side. So that means we could go up 2 and to the left 5. I think that's a skill you all are all pretty good at. So this is how we're going to graph that first one. We may also see some lines, this is very common in geometry, that are just our standard horizontal or vertical lines. So remember, when y equals 3, I always think about that as it's cutting through the y-axis at 3. So that line is going to be a completely horizontal line that is only going to cut through the y-axis because there's no x value at 3. All right, and then if I look at an x equals line, x equals means we're going to cut through the x-axis, so that line is going to end up being completely vertical, and so that's going to be x equals negative 4. All right, I also want to talk about some of the different forms that you could see when you're graphing lines. All right, so some different forms of linear equations that we might see. We've already talked about slope-intercept, y equals mx plus b, where m is the slope and b is the y-intercept. You may need to have that labeled. Horizontal lines end up cutting through the y-axis, so those are going to be any line that's y equals a number. So any number that you put there, y equals 3, y equals negative 8. Vertical lines end up cutting through the x-axis, so those are my x equals lines. We have standard form, ax plus by equals c. I don't know if you remember. This format is really good for graphing things when we're using intercepts, or maybe you called it like the cover-up method. But really the most important one for today, well, I guess there's 3. Horizontal and vertical we are probably going to look at today a lot. And then point slope is the other really helpful one. And so if we remember from Algebra 1, point slope is y minus y1 equals m times x minus x1. And the y1 and x1 are from a point that they've given us, right? That's why it's called point slope, because they give us a point. And then m is the slope that they give us. So the reason this one's going to be helpful is because parallel and perpendicular have relationship to slopes. And if we look at what those relationships are, we know parallel lines have the same slope. And that's because if they move at the same rate, the same rise over run every time, they're never going to be able to intersect one another. Perpendicular lines, we've talked about once this year already, have opposite reciprocal slopes. Opposite meaning we change the sign, and then reciprocal, okay, I can't talk and spell at the same time. Reciprocal, that's an O. Reciprocal means we're going to flip the sign. So, for instance, if they give us a slope, I've given us 3 quick examples down here at the bottom. If they give us a slope of 3, then the parallel slope for that is still going to be 3. So any line parallel will have the same slope of 3. Any line perpendicular will have opposite, so change it to negative, and then reciprocal, flip that, which is going to give you 1/3. And that's because the original 3 could be written as 3 over 1. All right, the second example, if they give me a slope of negative 2/3, the parallel slope is the same, negative 2/3, and my perpendicular slope is an opposite reciprocal, so change it to positive and then flip it, 3 over 2. With the slope of negative 1, my parallel slope is going to be negative 1, and opposite reciprocal, so change it to positive, and when you flip, remember 1's just 1 over 1, so when we flip it, it's still just 1. All right, I think you all should be good with those, so let's do 2 quick examples. All right, so here's our first example. They're telling me to write a line, the equation of a line in slope-intercept form of a line that's parallel to y equals 5x plus 1 and passes through the point negative 1, 2. So the first thing I want you to do any given time is to name the given slope. So our given slope here is 5, and our parallel slope is going to need to be the same as that, which is also 5. Now, we do want slope-intercept form in the end, but since the point that they give us is not a y-intercept, that's obviously not going to be on the y-axis, I'm going to use point-slope form in the meantime. So I'm going to start by saying y minus 2, because that's the y value for the ordered pair, equals the slope, and when I say slope, I'm talking about this parallel slope, times x minus the x value. And since the x value is already negative, I'm going to change this to say x plus 1. All right, now I need to get this in slope-intercept form, which means I need to get y by itself. So I'm going to distribute the 5. Y minus 2 equals 5x plus 5. And then I'm going to add 2 to both sides. Y equals 5x plus 7. So if we were to graph these two lines, the line that we just wrote and this other line, they would be parallel to one another and that they would not intersect on that same plane. Also, this line of the equation that we just wrote, right, that I'm putting a black box around, would not only be parallel, but it would in fact pass through this point that they gave us. All right, if they ask us to write perpendicular, so same instructions as far as the final answer, but now we need a line that's perpendicular and passes through a new point. So again, I'm going to start by naming the given slope. The given slope is negative 2 over 5. And you can be in the habit, like sometimes we just write out parallel and perpendicular every time, but this time I just need perpendicular. So I'm going to change the sign, make it positive, and then flip it to give me 5 over 2. So my slope I'm actually going to use is 5 over 2. So I'm going to go back to that point slope form. So y minus the y value. So since it's y minus negative 8, I'm going to write y plus 8 equals m, which is the perpendicular slope, times x minus the x value, or x plus 6, because the x value is negative. All right, now we need to distribute. So the y plus 8 stays the same. So when I distribute here, I'm going to get 5 over 2x. When I distribute to the 6, 5 times 6 is 30, divided by 2 is 15. So this is going to be plus 15. All right, so I'm just doing kind of a shortcut with the fractions. I can explain that in class tomorrow if you need me to, but really 5 over 2 times 6, that's just 30 divided by 2. Or you can cancel those first if you know how to do that. All right, and then I need to get y by itself. So last step is I'm going to subtract 8 from both sides. So y equals 5 over 2x plus 7, because I'm subtracting 8. So again, this equation that I've written is going to pass through the point negative 6, negative 8, and it's going to be perpendicular to this original line that they gave us, so that if we plotted both of them on the same graph, they would end up intersecting in a 90-degree angle. All right, this is what we're going to work on in class tomorrow.